Hi everyone, this lecture is on unit number 4 statistical methods. That is, in the question bank we have uh, problem number 18. Uh, the statement we have show that if theta is the angle between the lines of regression, then uh, tan theta is equal to sigma x into sigma y divided by sigma x square plus sigma y square into 1 minus r square divided by r. Hence here we have to show that angle between the regression lines in the form tan theta is equal to sigma x into sigma y divided by sigma x square plus sigma y square into 1 minus r square divided by r. So proof, see, here we know that if theta is acute, then the angle between the lines in general y1 is equal to m1x plus c19, y2 is equal to m2x plus c2 is given by, you see, tan theta is equal to m2 minus m1 divided by 1 plus m1 m2. Take it as equation 1. This denote angle between the lines, right? Next, see, now we have the lines of regressions. You already derived the lines of regressions. So those are the regression line of y on x and also regression line of x on y. So first one, consider the regression line of y on x, that is y minus y bar is equal to r into sigma y bar sigma x into x minus x bar. Take it as equation number 2. And another one we have regression line of x on y, which is x minus x bar is equal to r into sigma x by sigma y into y minus y bar. So now this equation we can also write in the form y minus y bar is equal to sigma y by r into sigma x into x minus x bar. The above regression lines also written in the form y minus y bar. Just cross multiply this, we get sigma y by r into sigma x into x minus x bar as it is. Just cross multiplying these. Next, now taking these as equations 2 and 3, y in terms of x, both these two, right? Because in general we have taken y1 is equal to m1x plus c1 and y2 is equal to m2x plus c2, right? So hence represent the equation in terms of y in x, right? Now consider the slopes of these two equations 2 and 3 are respectively given by first one. For the equation 2, the slope is given by, we can denote this by m1 is equal to r into sigma y by sigma x, because in the general equation, in these two general equation m1 and m2 denote slopes. Hence, just comparing these two with y1 equal to m1x plus c19, y2 is equal to m2x plus c2, then m1 is equal to, we get r sigma y by sigma x, and m2 is equal to, we get sigma y divided by r into sigma x. Now we have m1 and m2. On substituting these two in equation 1, which gives, equation 1 is nothing but tan theta is equal to m2 minus m1 divided by 1 plus m1 into m2. And see, on substituting we have tan theta is equal to sigma y by r into sigma x m2 minus r into sigma y by sigma x whole divided by 1 plus r into sigma y by sigma x into sigma y by r into sigma x. Now see, on simplifying, see, in the numerator taking sigma y by sigma x as a common, Hence we get sigma y by sigma x. Here remains 1 by r. In the second term remains r. Hence we get sigma y by sigma x into 1 by r minus r. Divided by here r get cancels. Then we get in the denominator 1 plus sigma y into sigma y, we get sigma y square. Similarly sigma x into sigma x, we get sigma x square. Again in the next step, sigma y by sigma x. So here taking LCM, which gives 1 minus r square divided by r, right? Divided by again here in the denominator taking LCM, which gives, here we have to multiply by sigma x square. Hence we get sigma x square plus sigma y square divided by sigma x square. At last on simplifying, here see this sigma x square divided by sigma x square. So 1 sigma x get cancelled. So this denominator of denominator goes to numerator. So which gives sigma x into sigma y divided by sigma x square plus sigma y square into this term 1 minus r square divided by r. Hence the proof. So hence the angle between the regression lines is given by tan theta is equal to sigma x into sigma y divided by sigma x square plus sigma y square into 1 minus r square divided by r. That's the proof. Thank you.